Hi everyone, this is again a nice question from Pathfinder. This is from um, Impulse Momentum chapter, okay, chapter 4 from Pathfinder. And this question states that a particle projected at an angle theta with the horizontal from the center of the floor of the cylindrical room of radius r. So this is the base of this cylinder, and from here a particle is projected at a angle theta, and it is said that it returns to the point of projection after three elastic collision with the walls and the ceiling. Okay, it is said that this particle like after three collision means from the walls. So after like thinking for a while, like it is and it is said that it is elastic collision, so the motion of this will be and symmetrical. Okay, so it hit this wall and will hit the ceiling and then the wall, and then it will return to it um, to its initial position. Okay, so we are so the question asks what is the speed of the projection. Okay, and it also said that the particle remain in air for time t. Okay, so let's begin. Okay, so we go into the question. So this is the cylindrical body, and from here a ball is projected. Okay, so as it's projected, it will have a y component and the x component, right? As we know, this y component is only responsible for this upward or the downward motion, right? And the x component is responsible um, for this forward or backward motion, right? So as the y component is upward, so it will move upward, right? General a basic thought is there, right? So it will move upward, kind of here, and by u, so it hit by the velocity v1. Okay, so with v1, and we know that we can, if we resolve the components, it will have a y component upward. Let's say v1y, and the horizontal sorry, and in the vertical, and the horizontal component v1x, right? So we know that as the uh, collision is in the vertical plane, so the horizontal component will be reversed. Okay, so as we know, it is an elastic collision, so the component will be reversed. Okay, so the actual after the hitting, so the velocity is upward and backward, right? The components, so it will move above, right? like this, it will have this kind of motion, so we can be sure that it hits the ceiling now. Okay, so after hitting the ceiling, the instantaneous velocity, um, so yeah, it will before the collision, it will have a v2 velocity. If we resolve this, the y component is upward, v2y, and x component is kind of there, v2x, right? As we know, the ceiling is in the vertical plane, so the sorry, it is horizontal plane, so the vertical component will be reversed, right? So actually it will have, and the velocities are in the backward and the downward, right? So it can be observed that it will have some this kind of motion, and again we can see that resolving the components. As the wall is vertical, so horizontal it will reverse 3x. It is downward, so it will have this kind of motion. We have accounted that there will be 3 collision, so this is how we describe this motion, right? So yeah, I have told you about the motion. Now you can proceed with your calculation, okay? And if you find any difficulties, you can watch it. So yeah, after having the knowledge of the motion, you can see that the x component will be same of the all the collision part, right? So simple knowledge, simple logic, right? So it will be u cos theta. So time period will be in the x component. So for the from A to B, let's say in the B there is first collision, right? Okay, right? So when the x in the x direction, the distance is r, right? So that is why we took t1 equal to r by time equal to distance upon velocity, right? So yeah, and for from B to C, let's say the time period is t2, and yeah, I'm just given that, you can see. So it is given in the question that total time period it is given. So we can say that t1 plus t2 plus t3 plus t4, it is t, okay. Yeah, so we can find it u equal to r by t cos theta, right? So yeah, if you have the depth of it, if you come to the depth of this question, you can be by looking at this equation, you can be like kind of think that why can't we just consider it as a full parabolic path of distance of range, sorry, 4r. So it will absolutely come the answer that this t equal to r sorry t equal to range by the velocity in x direction, right? So yeah, this is coming, but we have to keep in mind that the in the second collision, the y component is changing, right? So as you know that y component is the only thing like which will determine the time period of the parabolic path. Will the parabolic uh, as here the y component it is changed, okay. So in the normal parabola, what will happen that the y component will be tend to be upward only, but it is going down, means what, it will go down. So in the normal parabola it will go up, so time period will be more, and as it is going down, so the time period will be less, right? So that is what we use the condition, time period in this motion is less than time period in the normal parabola, and we know that the time period of the normal parabola is 2u sine theta by g if the angle of inclination is theta, right? So yeah, we again got this. So yeah, this is the answer, and if you like my explanation, comment down, and if you think that I need to improve my understanding and answering the problem, please comment down. I'm ready to change my explanation and everything. Okay, thank you.